Hey team, welcome back to my channel. In this video, you're going to learn how to prevent a console app from running multiple copies of the same app simultaneously. There's no better time to subscribe than now. Thank you in advance. The goal of this program is to take data and load it into a database. So I never want there to be two instances running at the same time. Notice here the name of my executable is called test command line with one switch R. So when I come over here and I say start running, and then I load up another instance, I want that second instance to not run. And notice this first one is running. And when it is done, no damage has been done to my database. That is what I'm going to teach you how to do in this video. Let's create a task schedule. Action, create task. Let's make an easy name, something that we can easily find. New. And then we can give it a small description, load data. And run, yes, I want to run 24/7. My trigger is kind of like, when do I want this to run? And I would like to run this weekly. Monday, Tuesday, Wednesday, Thursday, Friday, and I want you to run every 10 minutes and say OK. And then notice here, action, this is the program that needs to run based on this trigger. And I'm going to start our program and I'm going to go find that output file, test command line.executable. There it is right there. And I'm going to say open. That's going to come here in a moment. And then I want the additional arguments. Remember, that was a -R to get that running. And then I'm going to say OK. And now that I have this task all ready to go, I can say OK. Notice now, because I might not be here, I need to type in my password so this thing can run. Now we have a job that will run every 10 minutes, Monday through Friday. That's pretty awesome, yeah? Okay. So here we go. Let's write this app. Let's remove stuff so we can just explain what we're doing here. So what happens is we're going to say var MUTEX and we're going to create a new object. And this method right here, this class object, we're going to be using the one that has two parameters. The first one's going to say false and then a name. Now the first variable, that indicates whether the calling thread has the initial ownership. Now what does that mean? That's kind of complicated. So as C programmers, we can sometimes come out of a current app and execute another app, and it's like, do you want this new app to be part of that app, or do you want this app to stand on its own? And by saying false, you're saying, hey, this app has its own legs. Okay, I'm not responsible to anybody else. This second parameter is the name of the actual MUTEX. So in memory, think about this. When this app loads, it's going to go to this memory thing and say, hey, is the name of this object in memory already? And there's two ways that we can name this. We can either name it global / and then any name, or we can say local. Now let's talk about what local is first. Local means that somebody has loaded up their computer and I'm using it and I have a couple windows. Interesting. Now global means it's across all terminal services. So that means, like, if I log into a computer and someone else logs into a computer and this executable is on a shared resource and I'm loading it on my computer, they're loading it on their computer, then this can also prevent. Now, I say any name here. This is kind of dangerous. Our goal is to create a unique name. And a good way to do that is say tools. See where it says create GUID? And then I'll bang on this a few times and copy and paste this in here. And then I will harvest this GUID. So now the ability to someone come in there and generate this pattern is very unlikely. So I feel pretty good that I have a safe MUTEX name. Now this next one is, when our program loads up, we're going to go through that memory. We're going to wait 1,000 milliseconds, 1 second, and we're going to be searching, does this MUTEX already exist in memory? Is this program already running? And if it's running, then what we're going to do is we're going to show the user it's currently running, and then we're going to exit this program. Now, if it's not running, then what we're going to do is we're going to show this message that says long time running, and I'm going to do a thread. I'm going to sleep for 10 seconds. Now, you can imagine this program really loading data. Sometimes, remember, when I created that scheduled task to run, I said every 10 minutes I'm going to re-execute it. It's quite possible that it takes longer to load 10 minutes. Sometimes it takes 1 minute, 2 minutes, sometimes it takes 15. So on those times where it goes over 10 minutes, I don't want to have two processes running. Now, once we create one of these, it's best to do some cleaning up. And this is just general close and dispose. Now this app already exists. We're adding these from line 11 to 23 to the top of the program. And we don't need these lines because the process will actually do it. I did this for demo purposes only. Let's save this and compile that and see how that works. Excellent. Now what we're going to do is in the next video, we're actually going to see this program work. So here we go, team. I have two windows pulled up. I've loaded up my test command line exe with my -R in two windows. And I'm going to come over here and I'm going to execute here. And then I'm going to execute here. Then notice this one fails because this one's running. And this one is going to do whatever it does. And we're done. So that's the way that works. Now let me show you one other thing. If I come over here and execute this window, and notice I execute it, I say start running, and I come over here and I run that. As long as this thing is up in memory and that key is available, I'm never going to be able to run on this side. Hey team, thanks for sharing your time with me. Hopefully this video will be able to help you in the future. Please subscribe, leave a comment, and give me a thumbs up. I appreciate it. Thank you.